It is 4 p.m. sharp in Vienna, and this is the Global Routing Operations Working Group. Welcome, everyone. If you're not supposed to be in Vienna, come see me after the session and we'll try and help you. With me, I'm Job Snyders. I am one of your co-chairs. This is Paolo Lucenti, my fellow co-chair. Paolo lost his glasses. So whoever has the best one-liner joke about losing your glasses, please do take the opportunity before making technical comments. And our secretary, Lang Cheng, where are you today? Hey. Yeah, thank you. I took this photo 2 kilometers from here. I thought it was really funny. It's nice to be in Vienna. So today, we have a super packed agenda, which means we're going to do very strict timekeeping. There is no room for longer than allocated discussion. So when we start waving, like, stop, you have to stop as presenter. We'll go through our chair slides, and then we'll dive into the presentations. First of all, make sure you scan the QR code that's hanging off the microphone so we can try and book a bigger room next time, because the room is a little bit packed, I can see. How many people online?
I don't know.
So many. Yeah, okay. Routing is increasingly popular. Some resources for your consideration. We have a nice mailing list, grow@ietf.org. You can view the archive here. And there's a chat room that I'll be monitoring throughout the session. So if you don't want to walk to the microphone, but do have like a small question or comment, feel free to use the chat room. Pierre-Francois is helping us. He did not see it coming. All right. Note well, I implore on all of you, please be excellent towards each other. We are a bit of a debate club at the IETF, and the goal is to challenge each other's ideas and arguments. But that means no ad hominems, no specifics to affiliation or appearance, no shouting. Strive to be excellent towards each other. And your contributions at the microphone or in the chat or on the mailing list are considered IETF contributions, and that has a bit of a special connotation. If you want to read more about that concept, click on the links. All the blue words are clickable links, so if you download the chair slides from the data tracker, you can quite easily get to the content. Now, since our last meeting, we managed to publish an RFC 9972, one of the last ones of the vintage batch before 10,000. Advanced BGP monitoring protocol statistic types. Thank you to the authors and thank you to the working group for working on this document, and thank you for the patience. Then we have an internet draft that passed working group last call and passed IESG review and is now with the RFC editor, the near real-time mirroring protocol to replicate IRR databases. I expect this to be published somewhere in the next few months. Then we have an agenda item, and I'm going to pass the microphone to Paolo. It's
right. Small, agenda item around BMP. So we are very happy that there is a flourishing of contributions around the BMP, right? So We see there is, adoption among vendors, and there is new drafts being created. Sometimes, what we have recognized is that these initiatives they are not really sticking together with the rest of the protocol, with what has already been standardized or what is in flight at the moment, right? So duplication of frameworks, or things that really go the way. Okay, we invent 10 new message types and things like that. So we should try to be good citizens, like when we design the protocol, and try to make sure that when we make a proposal, it's sticking together with the rest, right? So we should try to aim at a good protocol design, right? And so because of that, with the job, we did discuss the matter, and we thought that we would like to do, going forward, a little bit of gatekeeping, right? The gatekeeping at the moment of document adoption. So the moment in which somebody says, I want my document to be adopted, we would like to have a little bit, not a lot of bureaucracy, but like a small form in which we will essentially be asking, like, so did you review the existing documents? Did you read them? Did you make sure did you do enough work to make sure that everything is sticking together in terms of design with the rest, right? And this is right to try to, have something more consistent. So we don't have any slides, or we don't have any, proposed, kind of form yet. We will go through it. Of course, we will submit to the working group. I mean, we will have a conversation. So for now, it's just something verbal. And of course, we are also, here, to collect feedback, like whether, anybody has anything to say about it or not.
Yeah. So to add a little bit to this, there is some concern about the long-term maintainability of the BMP protocol, and it has grown a lot in recent years. So going forward, we would like to hear from authors, like, what specifications did you study before you came up with this idea, to avoid, say, duplication of efforts, duplication of functionality. We also want authors to really investigate, like, do you need to extend an existing type, or is a new message thing needed, or like in what direction is the extension happening, and why is that direction the appropriate path? And this is to make sure that the BMP protocol doesn't become the DNS.
Right.
No offense to my DNS friends, of course. Are there any questions on this topic of gatekeeping?
Is there any support to this
Good question.
gatekeeping? Okay, Jeff. Okay.
We see 3, 4. Okay. Yeah. Okay. Thank you so much. It is good to see there is understanding and appreciation for this initiative. And a likely outcome of this is that we will develop some sort of checklist, or like a small interview form. But Paulo, as soon as he finds his glasses.
Exactly.
Yeah.
All right.
Next up.
I think next up is Camilo.
No, we're going to show the agenda. That's not all my slides. Look, I spent a lot of time making these slides with VI and Pandoc and LaTeX, so I feel bad if we don't look at all of them. Okay, our agenda for today is spread over 4 pages because there's a lot of presenters. Camilo's first, then Paulo. Prasad, Maria, Martin Pels will be remote, I think. Luc Hendricks. I'm really looking forward to what Luc Hendricks' slide looked like. Shuang, and then Tobias, is he in the room yet? Yeah, I can sense you. Okay. So, Camilo, take it away. This is the holy clicker.
Okay, thanks. Here, because I'm always bad at this. Okay, let's start with path marking. So Camilo Cardona from NTT. I'll give you the status of 3 documents, or the 3 of them working group documents. The first one is path status. For a short overview for whoever doesn't know, this is a proposed TLV for BMP that basically marks the status on the paths. What are the status? Whether the paths have been filtered, whether they are installed in the RIP, whether you can see this here, whether it's stale, suppressed, invalid, and things like that. This is an old document. I had presented this many times. What's new on this version of the document is that we have finally an implementation. Thank you very much, Huawei and Swisscom, for leading that. I'll describe this shortly. And this is something new. And I think it's been discussed also with the leaders of the group. Thanks to the now RFC that was published for the group, they did have a few statistics that basically did not belong so much in that document because they refer mostly about some things that we describe better here. So it was proposed that we move those statistics to this document, since we already have the space to describe all this status with more detail. Please take a look. I'm not going to go into much into it because I do want to focus more in that now we have an implementation of the whole path status TLB. Again, Huawei implemented in their NAAK series. Thomas and Swisscom did that effort. We use PMH, they use PMHCT, which are chair leads, and also NetGOS and Whiteshard for validation. So I think it works. We probably will look forward to a bit more information public when we can get it, but you can see at least know that this thing can be implemented. So the document, besides that, which is I find very important, has been more or less stable for already, I would say, more than a year. I honestly, at this point, would actually start asking for a last call if it were not that. We do depend on the TLB one, which we will have to wait for it because I don't think it makes sense to last call this one if that one is not last call. So we will be waiting. I don't know if I should talk about this one more until we get that one done. Do you guys agree on that?
Sure.
Okay. Questions or comments? Yep, I guess not. So we can go for the next one.
Yep.
Can you do it, please? Okay, fun. YAN modules. Our BMP YAN model. Again, it's also another old document. We got last year a lot of comments from Per, who is our young doctor. I don't think it's here. I can only thank him for that. Oh, I have to reset my timer. Paolo, come on. I cannot do this in one. And that distracts me. So we got a lot of feedback from him, a lot of editorials. We changed we tried to align with him on all the changes he proposed. I have to admit that from the YAN models, this one is big. So I can only thank him and any other reviewer for that. We also have, and I will talk about this in a second, an implementation status. So that's always very exciting. No, Joe, aren't you excited? Implementation. Yeah. And I'll try to discuss a bit about some dependencies we have with TCP. So let's start with implementation status. Arcus gave us a hand, implemented this module. I can only thank them for that. That's what we need. They did not implement some parts of the TCP auxiliary model, mostly about the TCP IO, which I'm going to talk in a second. But the rest, I think, has good coverage. I personally haven't seen it. but the comment so far is that the model is in good progress. So that's also a step forward in that regard. So I do have an open question for the group, which is our dependency with the TCP/AO draft. So there's a, I'll be honest with you guys. When we created the BMP YAN model, the first version, we modeled it a lot from the BGP model, and that one already had TCP/IO for authentication. And we added it to the model, even though it wasn't a standard for BMP. And now we have a draft. Jeff is there standardizing that. And therefore, we do have now kind of a normative reference to that one. The BMP model is actually in good progress, and I think now more in the last steps than in the starting steps. So the question is, what do we do? So we have a few options. The first option is we just keep going on this. Thomas helped me with, maybe we can follow this 4897 section 3.1 to just move forward. So that's one option. And that's the one that we will take by default, except if somebody yells no. The second one is that we actually push, so we can strip those parts from the model and ask Jeff and the co-authors of the draft to add them to their module. It's going to be less work from us, more work for Jeff. But that's also an option. The third option is that we wait. But of course, implementations for the TCP/IO and publication of that model of that draft can take some months or years. So maybe that's why I think we can just keep going and trying to use the 4897 if that's feasible. That's the question for the group. If anybody has an opinion, then please go ahead.
I'll keep it short. You're going to get pushback from the ISG if you don't actually have something talking about this. The nice thing about Yang is you can have, this is a requirement of the document. We have no work in the working group to say that we do want to support this. And anybody who does not support it can do a deviation statement in their Yang implementation. So nobody is blocked from using this, and it enables everybody to use it when it's there.
Yeah, and that makes good sense. That makes good sense. And we actually talk about this in the document already. So that's good. Thanks for that feedback, Jeff. Besides resolving this, I don't know whether we need a new reviews from the. I don't know how that works. I don't know if we need another review from the young doctors or if we need a shepherd. But I think we are more in that position of moving this forward than just waiting. So, Thomas now it's a young doctor. Maybe he can also take a look at his own draft.
I just wanted to double down what Jeff said. So deviation would be wrong in this case. I think what we want is a feature.
Okay. Well, we can think about that, but the point is that TCP/IO is also not a choice that you can ignore. I mean, there are a lot of caveats here that we can discuss. I don't know if we need a feature to add a choice. That could look a bit weird, even though it's feasible, of course, above all. Okay. So I don't know. Takeaway. Well, because really, takeaway for you guys, maybe. Sorry about that. Is whether we have to because I don't know how it works.
To respond to Jeff, I think if a BMP YANG model is created without TCP/AO, we can make a strong argument to pass it because we are documenting the current state of the art. So I'm not the ISG argument. I reject. So in that sense, if TCP/AO is not yet implemented for BMP. And if the document is not ready, remove it as a hard dependency, refer to it as work in progress, and yeah. Sorry? Or the bribes. Or, yeah.
How do we do that concretely? We delete it.
You polish the D button a little bit.
Okay, no, that's fine. We can also do that. Okay. That's it. Well, any more? I don't know if anybody has more questions about this. We asked for if anybody can look. I mean, if anybody's excited about BMP, please read the model. I mean, it probably should be part of the. No, actually, and I'm serious with this. It should be part of the. Since this is a working group document, whoever does a draft of BMP should say whether that model should be extended. From now
that's
on.
good feedback. Yep.
And because if it's not, then that means the model, well, all models are wrong, but it means that we need to rethink about this. And this is a working group document now, is the way. So I think from now on, please add that into your list of, and then we can have more reviewers, which is my final goal. Okay, thank you. Talking a bit more about BMP, this is the attribute about filtering flag. Do you ever presented this, Paolo, in other?
Quite some time ago.
Okay, so just to give a review of this, since it's my first time also, vanilla BMP, it was always considered that the streams from BMP were, let's say, complete. That the router was sending all the information of what it had in their RIPs. When log RIP came, I honestly don't know what the line of thought was, but they discovered that some feeds will be filtered, so they will not be complete. And they added a marker. It's a flag in the protocol. However, RBIN and RBOUT do not have that flag. But it's very feasible that RBIN and RBOUT are also filtered. For instance, in the BMP YAN module that I just described, well, I didn't describe, but I gave you a update of, it does have the option to filter those kind of streams. So by the same reasoning, the idea is that we also add that filter flag into RBIN and RBOUT. It makes the whole implementation a bit more uniform. If it's already in the local RIP, and RBIN and RBOUT can also be filtered, then it makes sense to have that filter flag. The filter flag is not going to tell the collector whether what is filtered or not. For that, I will recommend to you for the collector to follow the YAN module and get the filter path, but at least gives information to the upstream that something is not complete, and that's something that is already on the local RIP. So it just makes sense to make all of this uniform. We can try to implement this. I mean, I could take a SCAPI and add the flag, and then maybe ask Paolo to npm HTTP to output it in the JSON file that is followed. But at the end, this doesn't really need a big implementation. It's just formalization. So honestly, I don't know how much we have to wait, because to me, it just makes sense to continue if the group allows. Maybe in the mailing list. So I don't know what to follow here, but I will propose we just follow with last call. I'm normally not super aggressive on this, but this one I don't know what else to do.
So working group last call for filtering adjacent RIP in and adjacent RIP out.
Yep.
We will push the button.
Thank you. I don't know how to turn it off. I will just put it here. Hope it doesn't fall.
Next up, I think is Paolo.
Yeah.
You want me to help you?
What do you? The timer.
Yeah, the mic, it's right in front of you.
Yeah. All right. So
How long did you want? 5 minutes?
Yeah, 5 minutes. I will cut short the slides, because in the end it's okay, we talk BMP version 4, so the TLB support. I have my typical slide that recaps a little bit what is the draft. It is true that this slide is slowly becoming a little bit outdated, because it started with having TLV in root monitoring and peer down, but things are a little bit evolving over time. We have the enterprise bit right now, and we are bumping the version, and we have some new TLVs that actually apply to all the messages, like the sequence, the timestamp, and the flags. What happened since the last IETF. I mean, there were quite some changes to, not quite some changes, quite some edits to the document, but mostly it was smoothing out the fact that we merged the SNTS document in. And the main thing is that the SNTS document was really related to root monitoring. And then the moment in which we analyzed things, we said like, okay, but some of the content actually applies to all the BMP messages, like the TLV, like the sequence or the timestamp TLV and things like that. So we had to reward, a few things. Then there was quite some consistent review from Ayana. It was fantastic. So also that, took some time. But where I want to draw your attention is what's next. So I had a couple of very interesting conversations this week with Prasad and with Luke. So Prasad was saying dude, I mean, you are having a lot of TLVs and things like that here, but then we have this very rigid peer header. This being rigid, it will, fire back at some point, right? And especially we have some documents in flight, like the multi-peer header document that, it will, clash with the current rigidity. So essentially what Prasad was saying, I mean, we need something more flexible there. What it means more flexible, it means making the peer header TLV'd, right? So take all the static structure and you make TLV out of all the fields. This could be just one basic idea. We can work on that better. So Prasad was right. And then Luke came and said, hey, dude, like now we are doing all this TLV, now the peer header, it's also not rigid anymore and things like that. But now we have peer up and peer down, and we have quite some static structures there. We have the BGP PDU, the notification, or the open, and they are not contained into a TLV and things like that. I mean, this is looking quite ugly, for a protocol that is going into the TLV direction. Maybe we want to change that. And also Luke is right? So it was quite an interesting conversation. So my take was like, okay, we should try to wrap up this document, right? So this BMP version 4. But it's true that we have quite a good opportunity to improve the design of the protocol. And when I was talking, this was a point that was mentioned by Prasad, right? So it was like, we are not doing anything new, no rocket science, no reinventing anything, not introducing any news or whatever. This is just encoding and decoding. And encoding and decoding, probably it's the easiest thing that you can fix, especially, with LLMs and things like that. So like we can fix the encoding and decoding, and on the other hand, have a better design of the protocol, right? And I think, I mean, it's a valid point. I mean, it's, I kind of accepted it, but I'm very curious if there is any opinion on all of this from the audience. Thomas.
Yes, hi, Paolo. I think you already said in the beginning, it's time to wrap up. I looked in the data tracker. We are now 7 years into the document. We have dependencies on that document. We have implementations out in the wild. I'm an operator. I'm looking very forward on actually being able to validate or verify redundancy in the network. Without path marking, this is not possible. I'm looking at all the individual documents with all the different proposals. Normally, if I would go into another working group, like people would say, I think it's now time for a design team.
Yeah.
My suggestion here is I think we should stay as it is, wrap up as BMPv4, and then basically all these different proposals we have now, these different ideas we have now, let's form a design team on it and start working on BMPv5.
Okay, that's a good input. Thank you, Thomas.
Luc Hendricks, NLNet Labs. I'm all for somewhat more flexibility, maybe in the prepare header, but it's still a header. I would like to have stuff in a position that I know where I can find it. Making this a complete arbitrary thing is, of course, super flexible, but I don't think we should go there for that part of, of the messages.
Thank you, Luke.
I mean, I agree what Thomas said. I mean, he's on that journey, but on the other hand, if I know that V5 book is coming, I might wait and not go to V4 immediately. So that's the balance.
Exactly. This is always the problem when you start doing the next version and the next version, and the next version is not completed yet. Yeah.
But to be clear, V5 is for 2036. So
yeah. All right. Thank you.
Thank you, Paulo. Next up, Narashima Prasad, please.
Hello, I'm Prasad from Cisco. Today I'll be giving an update on 3 or 4 of our drafts. We've actually made edits to 2 of them, which is number 2 and number 3. And on number 4 and 5, we've had discussions. We've agreed on a certain direction to take, but we have not updated the drafts yet. So I'll be sharing the direction with all of you. And then while chatting with Paulo and few others, everybody felt that, especially for number 2 and 3, it'll be good to recap the use cases, especially if we can find some references in the public domain. So I'll kickstart the presentation with that. So the first one is the route reflector deployment use case. This was co-presented by Netflix and Cisco recently this year at RIPE 92. This is the network diagram is from their slide, but essentially what I'm trying to cover here is, especially for RR use cases, people want to use BMP. Netflix is keen on using it. They shared that in their presentation. And 2 other things which are important for us for these drafts is the scale of the routes. You can see it goes all the way up to 40 million routes/paths. And the number of clients which they want to monitor is around 300 at the max. So the 2 drafts which we have, which is the aggregated route mount draft and the common updates draft, kind of fit this use case. So mainly I want to just call out the scale signal here and the motivation. The next one is the edge deployment use case. This was shared at Nanog 97. It was G-Core, Fast, Netmon who presented this. So essentially what they called out in that deck is, I think they use Rotunda. Maybe Luke, you know about this. So what they were sharing is they had 3,000 BGP sessions, and then across the network, they had close to 200 million routes. But what matters for us is per router, they had close to 70 million routes. And then their intention was to use a live service provider network, which had multi-vendor deployment. So in that presentation, they share that it was across Arista, Cisco, and Juniper. And then main 2 callouts here is, again, the route scale and also the peer scale. You see that the total number of peers is very high. It's close to 3,000. This is where the multi-peer header draft and the aggregated route mount draft kind of help in addressing some of these scale deployment use cases. Outside of this, I've also seen similar use cases from other operators. So, but this is what I could find publicly from this year. Just to summarize those 2 slides, one is the edge use case, other one is the route reflector use case. So many sessions, a lot of routes, and then how do we optimize BMP to help both the router and the collector to have better performance and convergence. So if we help BMP with the convergence, the side effect of that is it will help BGP as well, because on the router both BGP and BMP kind of share the CPU. So in the Routemon draft, so this is the last sort of setup slide I have. After this, I have draft update presentations. So we are just leveraging the already well-proven BGP group packing technology, where it's called peer group, it's called update groups, but essentially the concept is you do the table walk once per peer group, and then you send all the updates out, and then you're packing things across the peers. So that is the essential building block from BGP, which is getting leveraged in BMP. So there's nothing new. It's a well-proven thing which is established in BGP. Yeah, I'll let you guys read this offline. Couple of callouts is fewer table walks. There is less work for the router, less data on the network. So hopefully it'll also help the collector side of things. I had a chat with Luke yesterday, and he did mention to me that it would help, because we were thinking if on the collector side, because there's so much CPU, if they would worry about this at all. Or is this a very specific problem for the vendors where the router CPU is kind of not as lavish as what the collectors run on? And he did say that some of this would help on the collector side as well. Yeah, so this side is calling out the best case scenario for both of these drafts. How much will the optimizations help with? So the two takeaways for you is with the aggregation Routemon draft, if you had n peers, if let's say we can share things across all those n peers, instead of sending n different messages, there'll be just one message wherein you would bulk all of them and send them out. This is exactly how the BGP packing works across the peers. And then, so that is within a review. And then the common update drafts kind of goes across reviews and says that if you're able to share anything across reviews, then let's say you have two reviews where you can share stuff, then there is a 2n:1 reduction. So this is the best case numbers, but the actual gain would depend on the commonality. Okay. Maybe I'll pause after I give an update on the drafts, and then you can ask me questions. So on the multi-peer header draft, this is where we made updates to the latest version, 0.2 version. So we kind of now are positioning the multi-header draft as a framework wherein you can use this not just for Routemon messages, but also for other use cases like peer down, route mirroring, peer up, and statistics. So we added those use cases in the recent update to the draft. But I do want to call out on the table on the right that the strongest fit I see is for Routemon, VC is for Routemon, and maybe the next one in the list is for peer down, where if there is a common failure, all the peers are going down, we can use the multi-peer header to sort of use this particular framework to group things and then send one big message with all the peer downs. And then would be route mirroring. I mean, this is where I think it just depends, because somebody may be using route mirroring because they want to see every small blip in the network. And if we start grouping things, maybe that is not to everybody's liking. And then there is peer up and statistics, where maybe what can be shared across different peers will start becoming less and less. So that's why we have marked it as conditional. But yeah, maybe here I'll pause and then get some feedback on what you guys think about the broader use cases and the stuff I presented before this. Any questions on that? Any comments? You think it's okay for us to extend it to other message types beyond Routemon? Any thoughts?
Luc and Rix, we also discussed this already offline, but maybe for the group. On the case of the peer up, and this might also apply to other message types, I can see that working for an IBGP scenario, but as soon as you start thinking of this in an eBGP scenario and you have your 32-bit ASN and the capabilities, every message will be different from the other, right?
Yeah.
In the route monitoring draft, you say you don't want to mix aggregated messages and non-aggregated messages, so you will need to use two streams. Long story short, it might need some text on operational considerations, right? I guess that's something to keep in mind when making overviews like this. I guess in general, it sounds like a beneficial thing, but we might have to study it on a per message type basis.
Thank you, Luke. Okay.
Hey, Pastor Thomas, I would like to understand what are the implications in terms of group TLV. Is there anything to be considered between the two?
Yeah, I'll update you on that in the next.
Okay, good. Thanks.
Thank you. So this one provides the framework. Our thought process was anything which is specific to the message types itself, like what Thomas was asking in the case of RouteMon, that can go into their own drafts. So that way we use this as a framework draft. And then if anybody is interested, then we can evolve the individual drafts for other message types. So this is where this draft update answers a bit of what Thomas was asking. So this is the aggregated RouteMon draft, which we modified to build on top of the multi-pair header draft. So in the earlier version, it was all V3. So we didn't have any option for TLVs and such. So in the latest update, Thomas, to answer your question, we've added the TLV way of doing things. So right now, both the options are there for both V3 and V4, but maybe as the draft matures, we would have to pick one. But for now, we've listed both, and we've listed how we can use the RouteMon aggregation across both V3 and V4. That is pretty much the update we did in this version. Actually, thanks to Luke, he also was asking us about this in the last IETF on how, can we use the aggregation RouteMon draft for with V4. Yeah, I mean, main feedback I wanted here was if you guys have any thoughts from the collector side, will it complicate things? Kind of goes back to what Paulo was asking from a codec decodec perspective. Okay. I'm not kind of calling out the proposed working group direction, whether we want the adoption or not. Maybe I'll wait for the template and then maybe we will take a call if we tick all the boxes.
Okay.
So on the common updates draft, which was across reviews, so this is a directional update. We have not modified the draft. So all of us co-authors discussed and we felt it's better to merge the common updates draft into the RouteMon aggregation draft. So that way we have one draft which covers the sort of the scale enhancement, so to say, in the BMP messages. So you will see us sort of taking this step if everybody seems to be okay with this. The plan is to merge the common update draft into the RouteMon aggregation draft, and maybe we will call it something else. But the idea is within a review, across reviews, we just have one draft which does the scale optimization. If there's no sort of opposition to this, we will go ahead and sort of do this. Okay. I don't see anybody objecting. This was another thing wherein, just to recap, the generic event notification draft was kind of covering the systemic events in BMP. So these were things like, did some review get unmonitored on the box, or was some peer configured but has been down for longer than a certain threshold. So there were a lot of things which were not route specific, but they were systemic or peer specific. So for that, we had a generic event notification draft. And before that, Paolo and Camilo already had the route event notification draft. which kind of covered all the route-specific event logging. So we kind of discussed amongst us, and then we felt it's better to have one draft for BMP, which can provide the event notification framework. So it covers, all kinds of things, not just routes, not just systemic stuff. So having one draft would be good. But what we have kind of discussed and decided on is it's good to merge them, but what exactly to merge, I think we're still trying to figure out. Should it be just the framework, which is there in the rel draft, and then the gen draft kind of calls out the specific use cases, or we merge the entire gen draft into rel? I think that we are still discussing. So if you guys have any feedback.
Sorry, you have 1 minute left.
Okay, sure. If you have any feedback on that, please let us know on if we just should have one framework and one in the rel draft, or we should just merge everything into one. Similar to statistics, we will start with the framework, and then we will have a few use cases defined for the events. And then as we go, if people have more use cases to add, just like statistics, they can create other drafts for this. I think that was my last slide. Yeah.
Oh, because in the lower right button, it says page 13 of 17. And I was like, oh, you still have 30% to go.
Oh, that was because I have some backup slides.
Oh,
In
I
case
see.
somebody wants
Yeah,
to read it
yeah,
offline.
Nice.
Yeah, all these additional.
Perfect timing.
Yeah.
Good job. All right. Question from the audience.
Hello, Nangang from Huawei. A quick comment. I think it's reasonable that we can have a common BGP event reporting framework. And maybe we can have some coordinations because the generic event notification draft shares, and one of my drafts share some similar ideas. And maybe we can have an offline discussion. Thank you.
Maria from BERT, I have a quick question. Should I review all your drafts now to check whether it's implementable in BERT, or should I wait until it's inside the group? What's preferred?
I mean, I would prefer some early feedback so that we are more prepared before the working group adoption. So if it's okay with you, I would request you to.
Okay, you're gonna put it higher on my queue. Thank you.
Thank you.
All right.
Thank you.
Thank you so much. Next up is Maria with route server next hop translation. And
let's get away from BMP for a while.
From Dutch to English, or what kind of translation?
Hello, holy clicker. Yeah, okay. This is a follow-up on RFC 8950. Which if you are deploying on a single link, it's completely okay. You can just unnumber the IPv4 addresses from the link. But whenever you happen to run it on route server, you find out that whenever you wanna unnumber one client, you have a problem because nobody else who is not supporting RFC 8950 can ever see the route. They will never get it, and they will never reach you. So unless you do a quick one-shot transition from nothing to everybody, you are stuck, and you have no motivation for actually running RFC 8950 on a route server at all. I summarized here that you can have legacy speakers who have no support for RFC 8950, and then you have supporting speakers. You actually have it, and who could actually receive and send legacy prefixes with IPv6 next hops. But the problem begins when you get the prefixes and you want to send them to somebody who doesn't support them. You have a problem. You won't even send them, and if you send them, it's malformed. So no easy way from that. So we need a transitional mechanism if we wanna go for route servers which eventually lose all the IPv4 addresses and go IPv6 only. There is the easiest way is the physical proxy way. You just set up completely separate two domains. One domain has legacy addresses with legacy next hops. The other domain has also legacy prefixes, but with IPv6 net hops. And then you have to set up a middleware, a middle node, which actually does BGP to both route servers and behaves as a proxy. This has some problems, like you have to send the data to the proxy, as can be seen here. There is one part doing the legacy routing, the other part doing the same thing but with RFC 8950, and then you set add path through the BGP proxy. You scrub the next hops to itself, and the traffic runs through the BGP proxy. And if you have one switch, that link to the between the proxy and the switch gets the traffic twice. Well, it's already deployed in some route servers, and it's allegedly working. But with the other authors, we decided that this doesn't scale. So another way is a virtual proxy. Instead of doing like a real proxy for the traffic, instead of it, you do like the same, but you set up a spoofer, and the spoofer is replying to the ARPs and NDs, because if you look at the schema, the clients which are called here B, G, and P, these clients actually don't need any IPv4 address. They can have only an IPv6 one, and it's enough to like virtually allocate them to them, and everything else is done by the BGP proxy, which spoofs the ARP and sends the actual information, sends the ARP reply instead of doing ND. This is a whole mess as well, because you are spoofing MAC addresses of different clients on your own network. This is kind of stupid, but it's also working. There were some experiments with this, but it has some drawbacks as well. So what we are, I have closed the queue. We have written the most of this draft is actually the mini proxy, which is the approach useful for networks running EVPN under the peering network, peering VLAN. And they are actually replying to ARPs and NDs on edges. As soon as you start doing this, you have ARP-free and ND-free network, and the access switch can reply to to the legitimate questions, to the legitimate ARP queries or ND queries to those machines, and they can actually choose whether they will have the table or not. So the only thing remains, and it's that you have to translate the BGP next hop which you receive between the IPv4 and IPv6, which is what this draft is about. You are already registering the MAC address of every client, and yes, you still need an IPv4 address assigned to every client. But with this technique, you can actually renumber as long as your IPv4 addresses are enough, you are okay. You can stick with them. And when you are running out of IPv4 addresses, instead of asking for bigger allocation or buying new block, you can go and decide with each client into which block this is going to be renumbered, and then if they don't like 8950, if they do 8950, you are okay. You can gradually renumber everybody to convert everybody to RFC 8950, and those remaining 5 networks who need the IPv4 next hops can get IPv4 next hops from, let's say, 10/8 or 192.168, whatever, from RFC 1918, or from the shared space, whatever you decide with them. And this draft specifies that you can do it actually for each client separately, because the translation is happening on the side which is facing the client. So you can do it like individually for each client, and you can do gradual remembering. Originally in this draft, there was a request to create, to allocate a piece of class E addresses for this purpose. I dropped this with my colleagues from this one because we found out that it was not crucial for this draft, and we are going to resubmit this probably into the area working group, because it's more like general, and it doesn't necessarily apply only to route servers. And yeah, this is how the Edge mini proxy actually works. The red part, there is no legend. Why? The red part is traffic, the blue part is BGP, and the BGP is translated when it comes from the IPv4, from the legacy part. It's translated to IPv6 next hops, and then back to IPv4 next hops whenever it's sent to somebody who doesn't like IPv6 in the next hops. And that's basically all of this. We think that the draft is basically done from our perspective. We think it fits the working group purpose. We already can configure this with BERT, so there is technically an implementation. We are going to look into other implementations, whether they are capable of doing this. And we'd like to ask you whether this is something which is for the working group. We'd like to request working group adoption, mostly because there is already an RFC which says that you should not, you must not rewrite the next hop. So this is technically an update to that RFC, which says you must not rewrite it. And this says, well, you can actually rewrite it if you want to do IPv4 to IPv6 and back. And that's it from my side. Questions, please.
So Tobias Hübich, Theowin. I just wanted to express my motivation for this draft and to work on this. So I would be very happy if the working group would decide to adopt this. And I believe that this is a good path forward to get v4 out of IXS, where it can be annoying, especially for renumbering.
Thank you.
Job Snyders, are you sure Grow is the best working group for this? Because the route server specification was done in IDR. This seems like you're fiddling with some protocol internals. Let me first say, like, this is interesting work. Let's find a good place for it to progress it. That is where I'm coming from. So, Jeff.
Yeah, I was sorry. Okay, I was living in a. I was thinking that this was some parts of the route servers were done here, but if I am wrong that parts of the route servers were done here, I may have read wrong.
No, so your memory is correct. The route server document was finalized here. It was from a long series of work that had been done before. So in terms of where it goes, it can go here perfectly fine. The thing that I would maybe challenge you for is you have a very specific use case towards route servers. This is a good thing. You had mentioned as examples some of the EVPN type work. If you find that this ends up being consultation with other people, this is more generic, let's move it to a different group than Grow, since it's outside route server at that point.
So you're saying the route server spec started as an IDR document, became a Grow document?
Nope, it started here, and the document actually started in 1990 something, as route servers were used, but you actually as part of building the internet.
All right. Well, we'll confirm where this should go, and then proceed.
Yep. Okay.
Any other? So aside from the procedures, any other feedback on the substance of this draft?
So for route servers, this is obviously a useful thing for some specific edge circumstances, as you're saying. So, for what route servers are being deployed for, this is great. For other circumstances, my personal experiences, things like EVPN and other things already have the other related features tied in. So this is more of an edge type scenario for that. The place that this might be an interesting scenario for is honestly for the service provider crowd. So getting some grow feedback on that respect about, well, what if your remote device doesn't support that? My gut feel from this is that at the service provider edge, this is typically done through static configuration and tunneling. So this is not a general problem for them. So I think we're sort of grinding the edge cases down to, the route service is really the only place that this is important.
Yeah, I was like, I don't have any other use case for this, but the route servers are hit by this. So it's specified for route servers. If anybody finds anything else that's useful for that this is useful for, please come to me. Tell me. Thank you.
Thank you so much, Maria. Next up, Martin Pels, dialing in remotely from the Netherlands.
Hello, am I audible?
Martin, I have the clicker here.
Just throw it.
You sound a little bit muffled. I don't know which microphone. Can you repeat the sentence?
Please be patient.
I am very patient.
Is this better?
Yes, thank you.
And Martin, you have control of the slides, so.
Yes, but I do not see my own slides. I still have Maria's slides here.
Yeah, I think you need to launch Martin's slides and then hand the control to him.
Oh, wait, maybe I can do that here.
Yeah, maybe click harder. Yeah.
There we go. Yes, so sorry for not being in the room with you. This is Yang data model for BGP communities updates. So very quickly, what we're trying to do is operators want to publish how they are using BGP communities in their network and the local defined fields in them. They can publish that in JSON or CBOR. And then parsers and looking glasses, for example, can download these JSON files and look at communities on the wire and derive meaning from them based on what's in the JSON. So the changes since the last time I was up here, the model has been restructured a bit to support augmenting other Yang modules. I'll go into that in a bit. And we've added an RPKI-based discovery mechanism. So first, the augmentation. So the module has been restructured so that each BGP community description is a separate grouping, and that way you can attach it to BGP communities in other modules, for example, IETF BGP module. Yeah, and there's an augmentation to that module. An example augmentation module is in the draft to demonstrate this. The next point is RPKI-based discovery. So the purpose of that is you want to know if a certain network publishes community definitions for their communities. For that, Job Snijders helped out with defining a new RPKI object type, a community definition reference, CDR. IANA has provided early registration of code points for this, and Job wrote a proof of concept for publishing an object and validating it in RPKI client. So the RPKI object looks like this. We have a version which defaults to 0. We have an AS ID, which is the autonomous system ID of the network that is publishing the community definition. Then we have the Yang revision of the Yang model that the JSON is using. And then we have a location, which is an HTTPS URI pointing to a JSON file on a web server somewhere that the operator chooses. And then parsers can download this object, download the JSON, and they match the autonomous system ID in the JSON to the AS ID in this object to make sure that they're looking at the right thing. And then they can use these definitions from the JSON file. So there are a few more open issues. So currently the descriptions for a BGP community subfield can be either a simple string or the value of the actual field. And now Maria is working on a draft in IDR to standardize how to display communities and other BGP attributes. And she's looking into using this module as well for that work. And she identified a few improvements. So for displaying, the important one was 1-bit flags. So if you have a community with many different flags, that are just simple 1-bit things, then it's a bit convoluted to handle that in the current module. And the second improvement she came up with was mapping tables. The idea of that is first of all, within a JSON, you could have a mapping table for example, country codes, and you refer to that one mapping table from multiple community definitions. That would be helpful to save some memory. And another idea is to have a mapping pointing to some IANA registered values so that we can have mapping tables that are shared between community definitions from different ASNs. So that's still ongoing. And then the other open thing is that I would really welcome more implementations, especially on the parser side, either standalone or as part of something like IETF BGP or other Yang modules, and other open implementations, RPKI publishing and validation, because we only have the one implementation by Joop at the moment, so more interoperability testing would be useful there. And that is all I had to share. Any questions? I see Luke in the queue.
Luke Hendricks. Hi, Martin. A question, maybe I missed it from the last version of the document, but about the CDR. So we're now able to get this all the way into the RP software, right? Now, how do I get it from the RP software into my software, so to speak? So far, this was an RTR thing, right? If I ever needed something from RP, I'm not sure whether this will be a thing that we should put in RTR. Maybe this is out of scope for this draft to begin with, but do you have any thoughts on this?
Joop, you wanted to comment on that?
Yes, sir. There is more in the universe than RTR. And what I envision for RPKI clients is it discovers the CDRs in the global repositories. RPKI clients spits out validated payloads in a JSON format. And this JSON format contains ROA information, ASPAS, BGP sec keys, and will contain CDRs. So the likes of PM, ACCT, and Rotunda slurp in the CDR, slurp in this RPKI client generated JSON and can do post-processing. Maybe in some future version, an RTR extension makes sense if routers can use the information in some way, but that is not this draft. So no RTR extension, just do it in the any API endpoint you feel comfortable with. So I hear a second implementation is coming. No commitment. Thanks.
Right. Thanks, Martin. And next up, I think, is Luke. We are a little bit behind time. So, Luke, we are going to allocate you 8 minutes.
Okay.
Yeah.
Yes. Okay. Back to BMP. During the hackathon, Colin and I tried to write some code for documents we've been working on, namely the one where we try to put BMP stuff into MRT, and the stuff that we then want to put in, that should be BMP snapshots, another draft we've been working on. I will do a short recap of that in a few slides. Because this should be doable in like 1.5 days, but then we realized, oh yeah, then we also have to actually do this full BMP version 4 stuff. But let's get cracking. So short recap: BMP snapshots. That's basically a mechanism to tie together a bunch of existing BMP messages, preceded by a new message type, namely a snapshot message, and a TLV with an ID that ties all these messages together. So we have a grouping of messages. Now, we reuse existing BMP messages, so you can use this on the wire from a router to a station, from a station to another station. But for this hackathon, we focus on the storing this to persistent storage. Okay, start coding. MRT. Let's open up the draft. Look at the common header wire format. 32-bit timestamps. Oh no. Scroll a bit further down. So this is basically your 2038 problem. We did the math. We can't retire before then, so we somehow have to fix this. And basically, the text also says, yeah, we know this is a problem, but this is a problem for future you. So here we are. We started thinking about how can we then actually fix this in a somewhat nice way. MRT is extendable. We can define new record types, but how are we going to do this? Are we going to come up with an extended timestamp record that we then put in front of every other MRT record that then contains our messages? Yeah, sure, that that might work. But what if you split the file? Because then you have to split on an even record number or whatever. And what's next? Because there will be another thing, right? So are we gonna make a generic extended TLV kind of thing? I mean, it fits in the working group, but this is a rabbit hole. We don't want to go there, right? In typical hackathon fashion, we were doing more talking than coding. And shout out to Akri. He joined our table and we started chatting about this PCAP NG thing. I guess we all know PCAP. PCAP NG is a very much more generic way of storing messages or basically whatever blocks of information. This is IETF work. The registration of link types is also will also become an IENA process. So this nicely fits into our basic IETF way of working. And if we could actually put the BMP messages in there, Wireshark has proper PCAP NG support. I mean, it basically came from the Wireshark people. So if this works, we can leverage things in Wireshark like their dissectors and their filtering. All good stuff. So we decided to diverge from the original plan. We need a custom data link type. If you know PCAP, you're typically thinking of the Ethernet link type, right? Where there is your Ethernet frame, and then there is some IP, and there is some layer 4, yada, yada. Maybe you've used it for 802.11 Wi-Fi stuff, but you can define your own custom stuff, so you only have to put in your, in our case, BMP message, and you don't have to worry about any other layers. And then basically, you follow the PCAP-NG structure. You have to write out a small section header block, a description about the interface where you can put in some extra information, and then you can start writing message after message after message. And then it's really close to how we know MRT in their update style file. It's just messages in very simple MRT records, one after another. So again, this is really not a PCAP as we usually know it for Ethernet type stuff. So visualized, what we did is we took a BMP feed from route views, and we started hacking on Rotonda. 2, for every stream, start writing out this section header block, the interface description block with our chosen data link layer type. And then for every message that comes in, we, first, of course, we write this snapshot message that's from one of these new drafts in an enhanced packet block. And we start converting all the BMP version 3 messages that come in, and we write them out with our snapshot TLV in these EPB blocks. You add the extension .pcap-ng, and for once, this actually worked. So this is a screenshot of Wireshark where we opened up our generated file, and now we have our BMP messages all together in this .pcap-ng. So these are some details on the actual data. I guess the most important thing here is that we put this stuff on the wiki to share in different variations. So there is the pcap-ng version. There's also just the bare binary version if you don't want to fool around with Wireshark, but just want to cut this towards your collector. And for both of these file types, we have the one with the snapshot and also the one without the snapshot. So if you are not interested in pcap-ng and you are not interested in snapshots, there is one which is basically a BMP v4 test data file. So that's on that wiki entry that still needs some love, but I hope that people start sharing other test data there as well, because I think we can do with a bit more sharing of test data within the working group. So what's next? I think that we are more in favor of pursuing this .pcap-ng route for storing BMP messages than bolting it on to MRT. So, we might, even though we just revived the thing 2 meetings ago, we will come up with something new. And for the BMP offline draft, which is basically the BMP snapshot draft, we'll continue experimenting with now the running code and the test data and update the document accordingly. And who knows, for in the future, we already have some ideas where we can maybe fix this problem in a more broader sense and start to store MRT records in a pcap-ng fashion that is useful for, say, the larger collector projects like RIS and route views without breaking all their historical collected data. But that's for another day. And with 39 seconds left, I hope I made up some time. Thank you.
Thank you. Please.
Alexander Azimov. I remember the old days when I was having a lot of fun trying to convert MET format to something readable. I wonder why you are trying to convert BMP data that normally is readable back to RMIT format. Okay, this slide makes me less anxious, of course. But anyway, so what was the foundation of your approach? So why do you want to RMIT back?
I never said I want MRT back. MRT was given to me. I mean, I was the first, to say a couple of years back when we started the new code base, like, let's do something different / better than MRT. But MRT is here, and it's, I guess, here to stay for a few more years. So this is an attempt to, slowly make things better. For some context, what we were trying to do is get a better variant of the MRT update style of files, right? So this is not the bview or the full dump kind of thing. For the BMP snapshot draft, we envisioned we could leverage what's in that snapshot draft, and then we have enough information in the messages itself to use the update style MRT files to get some state in there. I mean, this is a hard sentence also to, to say out loud, but so we could do with an MRT update style file, but because the MRT record type is not optimal, the closest thing would be the pkpng file. We get some tooling for free around it, but it's not replacing MRT altogether, because for that, I agree, we need something that is radically different, right?
JSON, zip.
JSON.
Okay, thank you.
Thank you, Luke. And we want Shuha. Sure, you also have 8 minutes.
Okay.
Sorry.
So, hello everyone. I'm Shuhe Wang from Zhongguancun Laboratory. So today I'll be talking about our fourth version of the draft, the requirements for monitoring RPK-related processes on routers using BMP. A little recap of our previous draft. We have divided all the processes on the routers into 4 stages, and namely, first is to acquire RPK data, and second is how the router configure RPK policy, and for the third stage is how each route is validated, and fourth is to observe routing impacts. And for all the 4 stages, they have one correlated view, is that the BMP should correlate what RPK data and policy existed with what happened to each BGP route. So in this version, I have mainly made 4 design changes. The first change is that I have, for previous concern, I proposed that 5 new BMP messages types, and actually each stage has 1 dedicated message type, and now in this new version I have reduced them to 3. And the following three changes are just come from the previous talk and advices in the mailing list. And for the first one is the SLAM become a first-class source and policy item. And second, in this draft, optional CCR-based dataset identification is supported. And third, we have explicitly clarified the boundary between the BMP and the YARN telemetry boundary. So the main direction for this update in this version is we try to narrow down the responsibility and a smarter protocol surface for BMP. So for the first change, is actually there is twofold. For the first one is I have combined the RPK source and RPK policy message type into a uniform RPK config message type. And second, for the RPK state message type, I have seen that there is already a newly published RFC that already defines the ROV states in the BMP RIP status. So we can just reuse this message type. And for RPK config, the data inputs can be multiple, like including the RTR, BGP, and static configurations. However, the SLAM may also change the validation dataset. So we propose that BMP should also report the addition and removals from the SLAMs. So the RPK config should report
not only the source type, availability, report counts, but also the update time errors, dataset identity, and for the dataset identity, because there may be multiple versions of dataset, the CCR could be used to identify the dataset. And here I want clarify the difference between the BMP and the Yang streaming telemetry. They are at the same stage, but different observation levels. For the streaming telemetry, it operates at the device level to report the troubleshooting information, including the RTR session information and cache synchronizations. And for BMP alone, it should focus on the routing context, which means what data was actually available and used for validation. And here's an example for if there are two. In this example, there are two RPK caches that are used, and a primary cache is fails. So for the Yang telemetry, it will mainly focus on the failure details, and for BMP alone, it will for BMP it will look at when the failure happens, what remains to be important for the validation process, which means the active source now, the effective data set, and the routing correlation. And here I want additionally discuss another problem, which is not strictly in the scope of the requirements, but is highly related, which is the engineering implementation of each BMP message at each stage. And here I picked the RPK validation. For RPK validation, the BMP message should report not only the validation state, but also how we finally come to the state. So here we propose a 3 tiers TLV data model. For the first tier, it should report the overall validation information. And for the second tier, is the validation rule records, which corresponds to the summary of each contributing rule. And for the third tier is just the detailed context of each contributing rule. And to realize such TLV model, there could be 2 options. For the first option, we can reuse the validation TLV in route monitors, and this could be easier to prototype, but may require duplicate reports whenever the data set is whenever the validation data set is changed. And another option is to just use a dedicated RPK validation message type. And finally, I want to emphasize the last stage. It is not frequently discussed in previous talk, but this stage is also important because even if the validation results are the same, the routes could be handled differently. It may be dropped, depreferenced, or just tagged. So the RPK impact should report the policy action as well as the routing outcomes based on the validation results. So for our next plan, we plan to further stabilize the requirements, and I plan to raise a new companion solution draft which specifically focus on the engineering implementation of the message type. And that's all. So
thank you. This is Maria from BERT. I'd like to note that this gathering all of this data would require to speculatively execute parts of the policies after the decision is taken, because the RPKI decision is not necessarily the last decision to be made before dropping the route or whatever.
Yeah.
So what you are basically imposing here is doing speculative execution on multiple ways in the code, all the way through after the best route selection, which happens possibly asynchronously after the route is received. So I would like to see either a lot of consideration of this, or better, a little bit of reduction of the scope, because the amount of information you are requiring is, I would not say impossible to gather, but expensive.
Yeah, okay, thank you.
Hello, Nangang from Huawei. Personally, I think the reported information in your draft may belong to a kind of reported events. So, there are some other proposals in the working group that to propose some new BMP messages to report routing events or some configuration events and some other events. So my opinion is that whether we can consider the event reporting designs or BMP extensions together. In the draft, maybe 3 new messages will be defined, and in other drafts are more, some other types of messages are defined. So maybe we can consider the designs together. That's my opinion. Thank you.
Okay, thank you.
Makes sense. I echo his comment and Nan's comment.
Okay.
Thank you so much. Tobias. Tobias, you are going to have 15 minutes.
1-5.
1-5.
Cut by a quarter and they were 20%.
Inflation. But let's see how it goes.
Yeah.
Getting mixed messages from the chairs there. I thought looking glasses were in scope of the working group, but one is missing them. So, welcome everyone. We're gonna do what we are doing every single time when we do Grow at an IETF meeting, except for last time. We're gonna talk about draft IETF Grow BGP OPSEC update and the accompanying drafts. So good news is that the first document has already passed working group last call, but we have 2 more to go, which roughly have 10 times as many pages. So overview of the document status. The main one, the replacement for BCP 194, has passed working group last call, but it is waiting for the 2 other documents to also do so, which the chairs informed me about at the beginning of this meeting. The second one, which is informal collection of options, methods, and things you can do to actually keep your routing secure. Hope being that if we make this an informational document and not a BCP, it's easier to update in the future and doesn't go stale as quickly, is making good progress, relatively complete. I see this go towards a working group last call in the next couple of months. And then there's also the terms document, which is thought to be something like what the DNS people are doing, but not as authoritative as what the DNS people are doing. Kind of trying to find our common language. That has some more progress, but still has some larger major organizational needs which have to be implemented. And as I see the room being way more full than in previous meetings, PRs are very much welcome. So, as I said, for the OPSEC update document, the working group last call has been closed. We are technically waiting for the Shepherd write-up, and I assume that that will be a bit out because the chairs are currently waiting to start the IETF last call until the other 2 documents are also going through working group last call, which kind of makes sense because one of the first feedbacks one usually gets for the first document is we would like to have all the things that are purposefully in the other documents in this document as well. At the hackathon, I don't know whether you noticed, sometimes rooms in this hotel tend to get a bit full. We were facing something similar. So we sat together with Jeff on Saturday, not in the hackathon room, but in a room next door. Still hope that the hackathon chairs are not unhappy that we didn't take a presentation slot. We had one further contributor at the hackathon who made a pass over the terms document and added a couple of terms and a spell check. And I believe overall, we are looking forward to kind of okay progress there over that weekend. We still need feedback though, because what we essentially started is Jeff, who I could also motivate to become a co-author based on the amount of feedback and lines he has contributed so far. Has started his full pass, which got over the course of the hackathon until section 7. And keep in mind, this is a roughly 50-page document. We need more people to do the very same thing. I don't know whether you remember the first document that had, I think, 5 pages or 6. And I have been asking for like 3 IETFs in a row whether anyone has read it. I would like to avoid that with that one, especially during working group last call. So if you have the time, go through that document, find things which need improvement, and send PRs. The draft IETF CyberOps Avoid APKI state in BGP is no longer expired. This was solved by it now being in the editor queue, which also is helpful. So we could just update the reference there. What we still also have to do is align the terminology we're using in the informational document with the terms document. So terms, for the terms document, we got 1 PR with a lot of spell checking, because apparently I was talking about a lot of divers which were involved with BGP, like the snorkeling type. But I learned that the Great Barrier Reef is not in Austria. Anyway, that document needs further additions. And I'm kind of hoping on all of you to contribute these. Like every single term counts. And if anyone feels particularly interested in having opinions on the sorting of this, especially what we do with the 3-letter acronyms and the definitions, do we leave them mixed up or do we cleanly separate them? I want to hear opinions on that. So let's quickly recall the original plan for these documents. What we wanted is we wanted to update/replace 194. So RFC 7454, if I recall that correctly. It should be short enough for policymakers to be able to read it. It should be generic enough to be resilient to specific terminology changing. So a little bit like policy documents in RIRs. It should be testable independent of the implementation, and it should be published quick enough to prevent harm. So we wanted to get this out in months, not years. I think that was at 117.
It was a few years ago.
Good, good. Just wanted to make sure because my memory with age gets worse. What we managed to do is we split out the individual X from that rather big basket. We have the one document which does policy. We have one document which provides, well, kind of informal guidance, and one on terminology. What we did not accomplish is be quick. So discussion points for now, because as you might have noticed, I did not really use that much time because usually there's not a lot of input over the course between IETFs. So I always try to get the people to provide input when they can't run away. You might see people blocking the doors. That's what we're going to do the remaining 9 minutes of this. So for the informational document, read it. You can start now if you want, but ideally within the next week. This needs more eyes and more PRs. For the terms document, pull requests are very much welcome. If there's something missing which you want to see in there, either drop a line like, please add this, then I'm happy to add that. Or if you want to make me especially happy, send a PR where you have added that term. And for the last one, so I heard about the plan of the chairs to wait for these other 2 documents. I can kind of see that going forward, but I would like to hear what the working group thinks about that as well. So thank you. And please, before we leave, let's talk about this. And if nobody wants to talk about this, you can also just replace BGP with an alternate method of internet communication. mean, that's also on the table. Hmm? We can go back to EGP. That's a good idea. And there the mic fills.
Alexander Azimov. A small comment related to the first, no, not first. I think first document. Yeah, the last one. It says in these three options. It speaks about altering BGP routes in one of its sections. And it mentions origin. And during this meeting, it was already discussed that origin, it looks like we should respectify what we are doing with origin. So I suggest to synchronize with people who are eager to put their hands in all these old attribute and its use cases.
Yeah, that's why we added Jeff as a co-author. Okay, so I think we stick with the agreement that everyone who doesn't walk to the mic volunteers as a co-editor.
Yep.
Good. I'm happy to see that much enthusiasm, and I think your time is then back in what it should be, right?
Almost.
Thank you.
Thank you, Tobias. And we have Nangang. And
the holy clicker is missing.
Oh.
You wouldn't download a clicker.
And then you will also have 8 minutes.
Okay, that's fine. Thank you. Good afternoon. Hello, everyone. I'm Nangang from Huawei. I will present the main updates to the draft on behalf of the co-authors. In the draft, we propose to report some routing events of BGP flow spec and BGP SR policies to the monitors. Okay, in the last IETF meeting, I presented this draft and received some comments from the working group. Thanks for the people who gave our comments. And the first is from Jeff. It's about UTF-8 text strings. In the draft, in our old version of the draft, we use log action TRV to carry the reported routing events. And one byte code point is followed with a UTF-8 string. This string can be used to provide additional information to the operators. And I had an offline chat with Jeff last weekend and confirmed the comment. And finally, in the latest version of the draft, the UTF-8 string has been removed from the log action TRV so that to avoid the difficulty of passing and interpreting this field. And we will also consider whether we need to add some other structured data in the TRV. And another comment is about selecting routing events. Thanks for the comment. We noticed that it's left in the minutes of Grow working group meeting. In the draft, we reported routing events, and these events are related to next hops. But when the network is unstable, the next hops may change dynamically, and there may need many routing events need to be reported to the station. So we have added some taxes in the operational section. Particularly, mitigation measures should be deployed for both the device side and the monitoring side. We also expanded the BGP SR policy routing events extensions. In the draft of version 0, there is only one routing event of SR policy reported, that is invalid candidate path. And in the latest version, 2 more routing events are defined, that is invalid segment list, and the other is exceeded spec limit. The section of operational considerations was rewritten. Will provide more details regarding to both the device side and the collector side or the monitoring side. Particularly, the device should need to report the routing events upon the corresponding routing events occur, and the devices can also selectively to report the routing events when the network is unstable, and this is corresponded to the second comment mentioned earlier, and some other details can be found in the draft. We added the request, INR allocation request in the last version. This section is to be done, and in this version of the draft, we have explicitly pointed out that we have INR requests. We also added Yu Jiagao as one of the co-authors. She comes from Zhongguancun Laboratory. We added this draft together. Okay, that's all. Thank you. Comments are welcome.
I have myself one comment. I've read the draft. It makes sense, like also how it is, nested inside the RHEL framework. So my comment was just about the title of the draft. Like it seems,
okay.
it seems very generic, like log more routing events in BGP monitoring protocol, whereas you focus on SR and flow spec. I wanted to see maybe a more fitting title for the document, and yeah.
Okay, thank you.
Yeah.
We will fix that in the next version of the draft.
Thank you.
Thank you.
Thank you.
Thank you. Thank you for not stealing the clicker like Tobias did. Did you see that?
I saw that. I saw that. I saw that. It was close. I mean, it was close enough.
There you go.
Okay. Hi everyone, I'm Jing Zhao from China Unicom. Today on behalf of my team to introduce the draft BMP extension for configuration monitoring TLV. First, I will introduce this document define two types of BMP extension TLVs. The first is configuration message TLV, carries configuration information associated with BGP routing changes. And the second is timestamp TLV, which includes the configuration summation, timestamp, and the configuration activation timestamp. These extensions enable BGP monitoring platforms to correlate BGP events with configuration changes, improving fault localization and troubleshooting for configuration-induced routing issues. And here we give two simple use cases. The first is survive configuration conflicts with the existing network configuration. A new VPN binding was added to the base station management lookback interface. It conflicted with the existing settings, causing private router to be withdrawn through BGP and all base stations to go offline. Without BGP configuration change data, operators had to trace the course of the failure. And the second case is IB overflow fault caused by relaxed import router fault policy. A relaxed import policy caused continuous IB groups. Months later, the numbers of router existed the device capacity causing FIB programming failures, unstable BGP seasons, and service outages. With configuration data in BMP, the monitoring platform could link the root inquiries to the earlier policy change and identify the cause more quickly. And the next is show the BMP extend TLVs. The first is configuration message TLV, including type, configuration season ID, configuration source, and the reserved field. And the second is timestamp TLV. It's including configuration summation timestamp and configure effective timestamp. And next is the scope of application of BMP message type. The BMP TLVs defined in this document can be included in the following BMP message type. The first is peer up notification. The second is tear down notification. And the third is root monitoring message. And the fourth is root event loading message. And next, we welcome your comment and suggestion to help improve the draft. Thank you.
Hi, this is Prasad from Cisco. I just had a quick comment that maybe we should look at the generic event draft and maybe the rel draft. See if they have the framework for you to sort of build on that for your use case.
Okay.
I think otherwise it's going to explode. We will have so many different use cases, everybody defining their own TLVs.
Okay.
So maybe we should look at helping improving rel and gen as a framework, and then build your use cases on top of that, perhaps.
Okay. Thank you.
Thank you.
And similarly to Prasad comment, I had also the comment that the timestamp TLV is already defined in the BMP v4 draft. So I was just not clear if you were extending that with some other code points or whether you were redefining it, right? Because that one applies to all the BMP messages. So.
Okay, we will consider about it.
Mm-hmm. Okay. Thank you.
Thank you so much. All right, we're at the last presentation. PAVA by Maxine Flechier. Is that?
Maxine Flechier.
I got it pretty close.
Almost.
Request to the working group to keep an open mind to this presentation.
Okay, thank you for the advertisement. I'm going to add that I know that GROW might not be the best working group for this work, but it technically fits the charter, and we can take it offline if you want to discuss somewhere else. So motivations. The idea is to do path validation in a different way. And why a new protocol when ASPA is nearing adoption in the side-drops working group? Because we in PAVA, we do some things with prefix-dependent added validations, which means that we can do fine-tuning of relationships, especially non-GAO export compliant relationships that are complex relationships. Also, it's an independent system from the RPKI for doing, I'm going to explain after. So for doing the querying, so we keep the information closer to the AS. There's no need to constantly go through IRRs to update information and or to have your own repository. And we catch all path forgeries, contrary to ASPA, in the way that Astra does it. So the idea is that we have two parts, a DNS querying to get the information and path verifications. The highlights. So Pava is meant to be run on a dedicated server and not on the routers, not to add load on it. It's done asynchronously, so DNS operations are not directly affected by the protocol. It is complementary to ASPA, so both can be used, and we even get more information when both are used. So it's interesting in that sense, and it should not take precedence over ASPA because it's like a different way of doing things. And also, and just as a note, the querying uses DNS, but it could be adapted to a different or similar system that is to be questioned or commented in the future. So the querying goes by cutting the AS path that we receive here at AS6 received a BGP update from AS1 for the prefix 1.1 and /16. And so the AS path would be here 5721, and we cut it into segments that overlap of 3 ASs, which each AS in the path at the middle of the segment. And this can form a DNS query that is sent to the DNS server operated by each AS that will ask for this specific prefix and this specific segment if it seems valid from the point of view of the AS. The AS then the DNS server will answer a status among up, down, submit, or error. That I'm going to describe right after. And the servers are not giving an answer. Then we give them an unknown status, which will be skipped in verification. And so like here, we get a few the answers corresponding previously to the path segments given. I'm going. Okay. So the different statuses are submit, which is like when we have like a customer to provider and peer-to-peer then link, and or customer to provider and provider to customer. So like the up of a link. The up status is when the segment was customer to provider, then customer to provider. Down is provider to customer, then provider to customer, or with a provider to customer after a peer-to-peer segment, and error in any other configuration, or if the AS path just doesn't exist from the point of view of the AS. Then after getting the list of status, we can run the verification so through the finite stage machine that in the end results in a similar idea to what is done in ASPA. So going up the list of providers and then going down, and that's basically it. But like unlike ASPA, we can verify small chain parts in the middle of the path and not just from the extremities of it. Also, so as I said before, Pava covers ASRA concerns and path forgeries that are covered in ASRA. So it does like both the work of ASPA and ASRA. And information, it doesn't have to be print downloaded because it's done offside. And we have DNSSEC on the queries to guarantee data authenticity. And what's next? So like the idea is to see if it sparks any community interest, and then to keep refining the draft, as there are like still stuff to do and a lot of precisions to be made. Welcome contributions if anyone's interested in the work, and maybe implementations down the line. if you have any question, comments.
Yeah, we have a few minutes left for questions or comments.
Oh.
Did it run out of juice? No battery. Yeah. Yeah.
Thanks. Making sure you're right. So Jeff Haas, thanks for the presentation. I added a little bit of context into the chat. Back when we were doing this original CIDR work, discussion about using DNS for this was one of the things. So I'd recommend looking at the archives. A thing that has changed since then is DNSSEC is deployable. That was not the case at the time. One way they characterize this is very similar to DNS black hole listing that you use for email. So I understand where you're getting some of the idea from. And having been running a mail server for 20 years and knowing how painful that fails, I'd be worried about putting routing security stuff into BGP. That said, there's also a proposal that is partially deployed for email called DANE, which is a generic mechanism. I realize that DANE's about the certificates, but it's also giving an idea about how to actually correlate services back. Maybe as part of your discussion in the next version, talk about how that's comparable.
Yes, it could be very interesting. I mean, I looked at DANE, and so it can be like put into the draft and all. So yeah.
Exactly. Thank you.
Yeah, Lan Cheng from Zhongguancun Lab. Just a brief question. So does this draft assume this is an online DNS querying method? It means when receiving a BGP updates, it will always trigger DNS queries towards every triplet on the AS path. Have you considered using some cache mechanisms, such like DNS cache or validation result cache?
There can be DNS caching on the thing, especially if like a route is propagated. I mean, there are like probably a lot of ASs will ask about the same. Exactly the same question. So DNS caching can be done in that regard. And
yeah, I think there are some space to optimization, so we can have talk later maybe.
Yeah. Okay. Thank you.
All right, the big shuffle of the microphones. Thank you so much for your presentation. I suggest if people have other comments or questions, send an email. This brings us to the end of our
on time.
We're on time. It's good. I would love to see all of you in San Francisco, if not there, Kuala Lumpur or online.
Exactly.
Thank you so much for your time and interest in the Global Routing Operations Working Group.
See you soon.
See you soon.
Kind of.
What happened? You left them somewhere you don't have.
I sit on that.